with the quadratic formula. And we're using the quadratic formula, remember, to solve for x-intercepts. And we would normally use factoring, but for whatever reason, factoring is not working. Maybe it's prime, maybe you're just having some trouble. And so our plan B is the quadratic formula. So when we're doing, again, this quadratic formula, we're always going to come up with a radical fraction. And sometimes students stumble with this radical fraction. So we're specifically practicing how to simplify this radical fraction. So you'll never see a problem that is just very isolated with this skill. It's always going to be part of the whole quadratic formula. But hopefully us taking the time to talk about this one piece and how to handle this one piece will make the quadratic formula go better. Now, our first step, we're always going to be simplifying the radical. And that radical, sometimes we have a perfect square, sometimes we have an irrational number, so that means we're going to have a radical left over. And we're going to actually look at something called an imaginary number. And after that, we're going to be looking at the constant, the coefficient, and the denominator. And we're going to be finding the GCF of those three numbers. And whatever that GCF is, we're going to use that GCF to divide. So again, all of these problems might look a little bit different by like number, but the general structure is going to be the same. You're going to see that plus or minus sign. That plus or minus sign, again, is coming from the quadratic formula. You're going to always start off with a radical. Sometimes you don't have a radical by the time you're done simplifying. Sometimes you still have that radical. And we're going to be seeing something with imaginary numbers as well. And again, that's a bigger topic for us to continue to talk about in the future. So let's go ahead and jump in. So our first type is when we have a perfect square. And so that means we're not going to have a radical left over. Now, the way that this video is going to show you how to simplify radicals is with a method called prime factorization. That is a skill that if you needed to Google that, you could look up that skill. You can also technically use, you can always look for perfect squares. But sometimes perfect squares are hard to find, especially if maybe you're not as well versed with finding perfect squares or recognizing perfect squares. So again, this video is specifically going to use the skill prime factorization, just in case you're having a little bit of trouble looking for your perfect squares. So first things first, I'm going to be looking for my radical, and I'm going to be looking for that coefficient in front of the radical. Now in this case, the coefficient of radical 16 is 1. I'm just going to pull this to the side. I normally pull this to the side just to keep my work organized. Now, some of you might know off the top of your head that the square root of 16 is 4. That is wonderful, great. If you don't know that 16 is a perfect square, that's why we're going to use this prime factorization. So we're going to break this down. So I can divide 16 into 2 and 8. Now I'm going to circle 2 because 2 is prime. I can't break down 2 any further besides 1 in itself. 8, though, is not prime. I can break that down into 2 and 4. I'm going to cross out 8 since we broke it down. And I can go ahead and break down 4 into 2 and 2. So the prime factors of 16 are 2 times 2 times 2 times 2. Now, you don't have to do this, but sometimes it's helpful for students when they're first starting out. I go ahead and rewrite this as 2 times 2 times 2 times 2. Now, remember that our index here, this is a square root, so technically my index is 2. So I'm looking for groups of 2. So it doesn't have to be the actual number 2, in this case it is, but I'm looking for a group of 2 numbers that are duplicates. If it's a duplicate, I'm going to pull one of them on the outside. The reason being is that technically 2 times 2 is 4, and the square root of 4 is 2. I have another group of 2's, and again, I'm going to just pull one of them on the outside as a 2. Now notice there are no numbers left underneath the radical. So if there's no numbers left underneath, I don't need the radical. And we're going to multiply the numbers on the outside. 2 times 2 is 4. So if I don't need the radical, really, I just have a 4 left over. So we know that the square root of 16 is 4. This number is going to be put back in the same spot as where my radical 16 was. Let's go ahead and rewrite this. So my first step is done. My first step was to simplify my radical. So again, first step is done. And now we want to rewrite it. So 6 plus or minus, and we have 4 divided by 6. So now we just need to rewrite. Then step 3, we're going to be looking for a GCF. Now there's no radical left over, so I don't really need to worry myself with that. I'm just looking at 6, 4, and 6. And hopefully we know that all of these are divisible by 2. So I'm going to divide the whole thing by 2. So I know that 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2, divided by 6 divided by 2 is also 3. Then we need, so after the GCF, we just divided. And then last but not least, we need to split. So the reason why we're splitting is because I have both a positive and a negative. So that means I can have 2 versions. I can have 3 plus 2 divided by 3, and I can have 3 minus 2 divided by 3. So I'm going to have 2 answers to this problem. So my first answer is going to be 5 divided by 3, and I can't simplify that, so that is what it is. And my next one, 3 divided by 2, is 1 divided by 3, and I can't simplify 1/3, so that is what it is. So I've got 2 answers, 5 over 3 and 1/3. So again, I first started off with simplifying the radical. I rewrote my problem once I simplified my radical. I figured out the GCF. I divided with the GCF. And then I split my fraction into the 2 pieces using the positive and the negative sign. Let's look at another one. So this one, when I go to pull and simplify the radical, notice it has a coefficient of a 2 in front. I'm going to go ahead and bring that 2 with me. It's just going to make my life a little bit easier if I simplify using this 2. Now this 2 is being multiplied with the radical. So we've got to make sure that this 2 comes down with us. So I'm just going to draw an arrow down below so that way we don't forget about the 2. It's going to be used a little bit later. Let's go ahead and break down 121. Now again, 121 is a perfect square. Some of us might recognize it, some of us might not. The only number that is divisible by 1 with 121 is 11 and 11. These are both prime. Again, the idea that technically I have 2, and that's going to be times the square root of 11 times 11. Just like before, we said that this is a square root, which means that my index is a 2. So I'm looking for groups of 2. So I've got 2 11s, so I'm going to circle that. And again, one of them is going to come on the outside. I'm going to cross that out. So again, question ourselves, do I have any numbers left underneath the radical? The answer is no. All we're left is 11, and we're going to multiply that with 2. So 11 times 2 is 22. And again, no radical, so my answer right here is just 22. This number is what's going to get replaced in my problem. So I'm going to rewrite. I should have 3 plus or minus. And now instead of 2 radical 21, I have 22 divided by 4. After I rewrite, I'm going to find the GCF if I have one. Now, if I look at this one, if I'm looking at 3, 22, and 4, now I know that 22 and 4 is divisible by 2, but 3 is not divisible by 2. 22 is not divisible by 3, and 4 is not divisible by 3. So in this case, there's no GCF. So I can't divide, I can't simplify this further, and that's okay. Sometimes that happens. So we're actually going to skip down to step number 5. We're going to go ahead and split this into its 2 pieces based off the positive and the negative sign. So we have 3 plus 22 divided by 4. And we're going to have 3 minus 22 divided by 4. So that would be 25 divided by 4. And again, that can't be simplified. So that is what it is. So 3 minus 22, that's going to be what, 19? Yeah, so it's a negative 19. I'm going to go ahead and write this underneath. So negative 19 still divided by 4. And again, that cannot be simplified. So these are my 2 answers. All right, next we're going to look at some problems where we have a radical left over. So if you notice again, for these problems, once I simplified the radical, we did not have a radical left over. But in the next ones, we're going to have a radical left over. So these are called irrational because, again, they've got that radical. So let's take a look. So C. So think about what am I about to pull to the side to simplify. So think about what I'm about to pull to the side to simplify. So I'm going to be pulling 3 radical 12 to the side. Don't forget that we're going to be bringing our 3 down with us, but we can go ahead and break down 12 into 6 and 2. I'm going to circle 2 because it's prime. I'm going to break down 6 into 2 and 3. And again, I'm going to circle 2 because it's prime and 3 because it's prime. I'm going to go ahead and rewrite here. I've got 3 on the outside and then a radical 2 times 2 times 3. Again, this is a square root, so I'm looking for groups of 2. I have 2 2's. One of them is going to come on the outside and get multiplied with 3. It's gone from the inside, but notice I have a number left over underneath the radical. There's a good old little 3 right there. So when I go to rewrite, 2 times 3 is 6 here on the outside. But now I have a radical 3 here because, again, that 3 didn't have a partner. There wasn't 2 3's. There was only one of them. So I have 1 left over. So this is now what's going to get put back in my expression. So let's rewrite this. I'm going to have 10 plus or minus. I'm going to rewrite now 6 radical 3 divided by 4. All right, we're going to look for the GCF, but be careful because now we have a radical in the mix. When we find our GCF, we're only looking at the constant, the coefficient, and the denominator. In a weird way, we're kind of ignoring the radical. We can't just get rid of the radical, but we're just ignoring it for the moment. I'm just looking at these 3 numbers, and I'm trying to figure out what is in common between all those 3. How are they divisible? So the GCF here would be a 2, which means I can divide them all by 2. So 10 divided by 2 is 5, plus or minus 6 divided by 2 is 3. I still have a radical 3 here. Divided by 4 divided by 2 is 2. All right, and now I just need to split into my two answers. So again, with that positive and negative, we're going to split. So we've got 5 plus 3 radical 3 divided by 2. And then we also have 5 minus 3 radical 3 divided by 2. And those are my two answers. And real quick, sometimes students want to know why they can't actually add like 5 and 3 and subtract 5 and negative 3. Well, it's because this 5 does not have a radical 3. So like, for example, if I had 5 plus 3x, can I combine that? No, because this 3 has the x. So just like I can't combine 5 plus 3x, I can't combine 5 plus 3 with a radical attached to it because they're not the same terms in a weird way. So the 5 would have to have the radical 3 in order for us to add that with the 3 that's here. So just a quick little kind of explanation of why we can't actually add these and why we can't actually subtract these. And again, it's because that radical is attached to the 3 and it's not attached to the 5. And we need to make sure we would be combining like terms. All right, let's look at our next example. So think to yourself, what would I be pulling out to simplify? We would be pulling out a negative and then the radical 97. 98. Let me go ahead and break that down. So we can divide 98 divided by 2. So it would be 2 and 49. And then we can break down 49 into 7 and 7. So I'm going to rewrite. Don't forget you have that negative sign in front. So you're going to have a negative and then radical 2 times 7 times 7. And again, there are 2 7s. So I'm going to be pulling 1 and multiplying that on the outside. Notice I have a number left over. I have a 2 left over. So I'm going to have radical 2. Technically, this is a negative 1 in front of the radical there. So realize 7 times negative 1 is just going to be negative 7. So this is what's going to get put back in my expression. So I'm going to rewrite. So I have 7 plus or minus negative 7 radical 2 divided by 7. Now, some of us might notice this early on. Notice how we're having a lot of signs here in the middle here. We're going to handle these later. But yeah, we're going to need to clean up these signs. But we can go ahead and do it later. Some of you can figure out how to do it now. Ms. Hinchman's just going to wait and do it later. What we're used to doing now is we're used to finding the GCF. And again, we only want to do it to the constant, the coefficient, and the denominator. We're going to ignore the radical for now. Hopefully we know that all of these numbers can be divided by 7. That's our GCF. Oops, I wrote a 2. There's 7. All right, so let's go ahead and simplify this. 7 divided by 7 is a 1 plus or minus. Negative 7 divided by 7 is a negative 1 radical 2. Divided by 7 divided by 7 is 1. Now there sure are a lot of 1s around here. We got to figure out which ones we can keep and which ones technically we don't have to write. Now if you write them, they're not wrong, but you just don't have to write them. So let's take a look. I'm going to have 1. We definitely need that 1 because that's like a constant. Plus or minus. Now if I'm multiplying with a negative 1. I definitely need the negative, but I don't have to write the 1 in front. I could just write radical 2. Now this is divided by 1. I don't need to write divided by 1 because if I divide a number by 1, it doesn't change it. Like 5 divided by 1 is just 5, or like 20 divided by 1 is still just 20. So I don't need to divide by 1. So we're almost done. Now we need to split into our two pieces. So we're going to have 1 plus a negative radical 2. And we're going to have 1 minus a negative radical 2. So again, we split because of that plus or minus sign. So there's my plus sign and here's my minus sign. Notice how I still have the negative sign in front of the radical 2 part. Now, all of that's really important because now we can easily see how to clean up our signs. So this is, again, why I normally wait till the end to clean up the signs, because I think it's just easier to see where to clean them up. So hopefully we would recognize that if I'm adding a negative, it's just overall a negative. So this is going to end up being 1 minus radical 2. And hopefully we are comfortable knowing that a negative times a negative is going to be a positive. So this will end up being 1 plus radical 2. And again, I know that sometimes the signs can get a little tricky. This is not the last time we will see problems that have kind of some issues with signs. But again, it's just sometimes easier to, at the very end, to notice what you can simplify with the signs. All right, so last but not least, so our last situation is dealing with imaginary numbers. Now, I want us to notice something here in this last example before we go on to the next one. We had a negative on the outside of this radical, and notice that negative stayed with us on the outside. So a negative on the outside, cool, no worries. But now we're going to start to look, and we're going to be finding a negative that's under the radical. So again, we're looking at a negative that is under the radical. If you have a negative that's underneath the radical, what you actually have is an imaginary number. Ooh, imaginary. I know. Sounds really fancy. It really is not that fancy. There's going to be a separate video that's specifically going over what exactly an imaginary number is. For now, I just want you to recognize, I have a negative underneath the radical. I'm about to show you what we're going to do with that negative. So, just like before, I'm going to look at my problem. I'm going to look for the radical and the coefficient. And again, I'm going to bring this to the side so that way we can simplify. Now, if you see a negative number under the radical, so again, negative under the radical, what we're going to be doing with that is we're going to be taking that negative and we're going to be bringing it to the outside. Once we bring that negative to the outside, it's going to become an I. So this will look like 6I radical 14. So that negative is not switching to a positive. That negative is switching to the variable I. So again, if there's a negative under the radical, not on the outside, but underneath it, we're going to bring that negative on the outside and we're going to write it as an I. Once we do that, we can just treat this problem like normal. So let's look about how to break down 14. That would be 2 and 7. But notice if I go to rewrite this, do I have any duplicates of a number underneath the radical? Do I have 2 2s or 2 7s? No. So in this case, I cannot simplify radical 14. It's going to stay the same. So I'm going to have 6I radical 14. And this is what we're putting back inside our problem. So I'm going to have 2 plus or minus 6i radical 14 divided by 4. Just like before, I am looking at the constant, the coefficient, and the denominator, and I'm asking myself, is there a GCF? Our answer should be yes, and it should be 2. So that means we're dividing everything by 2. So that means we will have 1 plus or minus 3, don't drop the I, radical 14, all divided by 2. Just like before, I'm going to be splitting my positive and negative sign, my plus or minus sign here, into 2 pieces. So my first one is going to be 1, and I could do minus or plus, it doesn't matter which one I do first. I just normally like to do my plus, so 1 plus 3i radical 14, and that is divided by 2. We also have our negative version, so it's going to be 1 minus 3i radical 14 divided by 2. And those are our final answers. We've got 2 solutions. And again, notice that I stayed with us the whole time. And again, it's on the outside of the radical instead of on the inside. And again, for now, this is something that you're just gonna have to be like, oh, okay. And know that you're going to get a lot more information of what this actually means. We just want you to know the process for now. Let's do one more. So again, think to yourself, what is Ms. Henchman going to be pulling out to the side to simplify? Hopefully you're thinking about this 4 radical negative 12. And again, we have to notice, ding, 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 there is a negative underneath the radical. That's an issue for us. We are going to remove it, and we are going to make it on the outside an I. So this is going to look like 4i radical 12. So again, if there's a negative underneath the radical, pull it on the outside and make it an I. Now let's break down 12. That's going to be, we could do 4 and 3. 3 is prime. 4 can break down into 2 and 2. I'm going to rewrite this as 4i square root of 2 times 2 times 3. Again, I've got 2 2's. How many are going to come on the outside? One of them. I'm going to be multiplying that with 4i, and I'm going to cross this out underneath because I don't need that anymore. 2 times 4i is 8i. And then I have a 3 underneath my radical, so radical 3. Again, this is what's going on the inside of my expression. So I've got 8 plus or minus 8i radical 3 divided by 16. Again, I'm going to look for that GCF here. My GCF is an 8. So that means we're dividing by 8. So let's go through it. 8 divided by 8 is 1. Plus or minus 8 divided by 8 is 1. But I still have the I there. So I'm just going to have an I, like 1i. Radical 3 divided by 16 divided by 8 is 2. All right, I'm going to write this into our 2 pieces. So I've got 1 plus I radical 3 divided by 2. And 1 minus I radical 3 divided by 2. All right. Again, this is not the last time you will see this process. We will be looking at this process when we do quadratic formula. But again, this is normally where students have the most issues within quadratic formula. So please make sure you're paying attention and definitely rewatch the video if you need to.